Hello students, my PIMA Maths 142, and this is lesson number 2.4 on conditional probability. So these are the problems exercise. If you see the packet that you have, uh, if you see turn 4 pages, then it starts with problem one. So I thought of making this video so that some of you, if you feel that if find it difficult, so that will help. Okay. Now, what the first problem is given, two events A and B are given, and their probabilities are given here, and also their intersection is given. The question is, what is the chances that A will occur once you know that B has occurred. Now, what that means is we have to use for the first one, A, let me write it here. So probability, the formula, conditional probability A when B has happened is probability of A intersection B and divide by probability of B. So this is the conditional probability formula that we have to use. And then you just have to plug this in 0.29 and divide by the B 0.48. And when you work out on your calculator, you end up getting 0.604. So that's the first one. The second one is probability of B when A has occurred is the same formula. The numerator stays the same, probability of A and B, and the denominator will be probability of A. So when you work this out, so A and B is this is 0.29, so that's the same, and the denominator is this one, which is 0.73, and if you work this out, you get 0.397. And there is one more question: is what is the probability? Oh, and the question is asked: are these two events A and B independent? Now, what is the definition of independent? Two events are independent. Two events are independent. Okay, when if probability of A when B happened, that means if B has occurred does not affect the probability of A. So the probability of A is same as probability of A when B has happened. So now let's first figure out what is this piece, probability of A. Probability of A is already given to you as 0.73. And probability of A when B has occurred is this piece. Here it is. And that is 0.604. And you can see they are not equal. So that's why we say those two are not, these two events A and B are, are not independent. Okay. And then now the conditional probability, remember probability A and B, see, this is also called multiplication rule of probability is probability of A, B, let's see, times probability of A when B happens. So just in case, just in case we happen to get these two pieces equal, if these two are equal, then this will be probability of B times probability of A. So that means you get probability of A and B is directly just multiplying the two probabilities. So though this formula reduces to this only when they are independent. We will see that in another problem how that happens. So okay, so the goal is to show that the question was, are they independent? So you can see this is not equal, so these two pieces are not same. So the probability of A, so what does that means is this probability of A gets affected by the B. So whatever, so they are not independent. So A depends on B. So let's take another problem. In the second problem, again you're given this is just to reinforce or build up your skill to understand this. the conditional probabilities and independent events. So you're given these three pieces yet again. So all you do is this equal by definition. This the conditional probability formula is probability A and B divided by probability of B. Okay, so this becomes equal. A and B is given at 0.01, so this is zero point 0.1, and divided by B is given 0.37. So that equals, uh, in the we'll write down to three place decimal 297, and then let's do this B piece will be probability of B when A has occurred is again probability of A and B divided by probability of that. So if you see this A, that A goes down right here, and then like plug in this 0.11, and then divide by point the probability of A, which is 0.2, and if you use the calculator, you get 0.423. Okay, so that takes care of the two questions. The third question is whether or not the A and B are independent. So we have this piece and we want to know, is this equal to probability of B? Now, what is probability of B? It's already given to you, it is 0.37. You can see these two pieces, they are not the same, they are different, so unequal. So because these two are unequal, and we can say that probability of B and when A has occurred is not the same as probability of B. Okay, so that's why we say A, B are independent. In other words, also this multiplication rule also fails. It means probability of A is if two events are independent, then it's always this this formula works. It means you just have to multiply the two probabilities. That's because this probability is same as, if I want to write here, this probability is probability of B when A has occurred. This piece becomes equal here. So that's why in this example, you can see those two pieces are not same. And because these two pieces are not same, then we can say they are not independent. Okay, I hope. So we'll take one more and see how that really works. Okay, let's see. There's another question. Find two events are given, A and B. Their probabilities are given one. Then you are given this, and also their intersection. And clearly, what does this basically means? There is a we can make a Venn diagram here and say, okay, this point 15 basically means out of 100, it is like 15 here. Okay, just to get an idea. This is event A and this is event B, and this is like there are 25 here out of 100, and this is B is like 60. So from 25, so how much is this will be this piece will be 10, I think 25 minus 10 and 60 minus 50 will be 45. If we add up all this 3, 10, 15 and so if we add 10 and 15 and 45, that will give you one here 370. So that will be 70. So 70, that means from 100, if I take off 70, you get 30. So that means this becomes 30, the outside the two ellipses. So what that basically means, let's see. First question is, let me first solve the problem and then show you how we can also do directly. So uh, first is probability of A when B has occurred. So what is the meaning of this is probability of A and B divided by probability of B, and this is here it is 0.15. A is the common and divide by this is 0.6, And if you use the calculator, you will get 0.25. This will be 0.25. And this answer, this I'll write B here. Probability of B when A has occurred, again the same thing. Probability of A and B divided by probability of A. Okay. So now probability of A and B is here 0.15 divided by A is 0.25. Okay. And if you use the, of course, it is 50 now, if over 25, using the calculator, you get zero point 0.6. Now, the third question is asked. So, this is done. This is done. But are the two A and B independent or not? How do we know this? Now, from we want to know this is B when A has occurred. What about probability of B by itself is given as 0 0.6, and you can see both are same. So these two pieces become same. So what did we learn from here is that probability of B when A has occurred is same as probability of B. So which is 0 0.6 is 0 0.6. So the conclusion is A, B are independent. They are independent. Right? So that was understanding of whether what is the A and B are independent, and also from here we can also find out by just now look at this. This piece we could also use this and get directly. What does that basically means? So this means A when B has occurred. It means first you have to think of the B piece. See, this is the B piece. This is the B, right? And from B, you are thinking of A. So the from B, A will be, let me use some. A will be this 15, see, this part. So it is 15 over the red one. So it is the 15. So this piece is 15 divided by the red color 45. See how easy it is? So you can, if you draw the Venn diagram, you can easily get direct answer saying that, okay, probability of A when B means you first choose the B. This is the B. And from this B, what is the part that is A? And then you can see that's 15 there, so the 15. So this is 15 there. So this 15 inside this 15. So is right here. Okay, which the calculator will give you the same answer. And you can also, if the second question is B when A means, again, you have to, this time you have to think the green one. Let's say this whole thing is the B. Sorry, this is the A. And from A, so A has occurred, that means out of 25, this will be out of 25. A has occurred. And you want to know which is common, which is there for B. So B is again the same 15 will go up like this. So easily we can find out these two pieces if you use the Venn diagram without using the conditional. This is using conditional probability formula. Okay, so one more thing I wanted to show also is, okay, I think, oh, there's one more question there. I just wiped off the whole thing. Okay, anyways, so let's do the last one. Check whether A and B are, what is mutually exclusive? Now, what is the mutually exclusive basically means? If I have a Venn diagram, see, either in a classroom, I can have boys and girls. So these are boys and these are girls, okay? So in the classroom, there could be 15 boys and 13 girls, and we say, okay, this is B and this is G. So we say uh, uh, B and G, you don't see any student common. So we say this is empty. This is null. There is nothing. It's empty. Okay, this is like this. In other words, we say probability of a boy and girl. That's what it is. A girl and a boy is we say, hey, there are even though there are 28 students here out of 28, and you don't see any student which is common, who is boy and a girl, so you just put zero. Just like number of outcomes of G and boy and girl is zero. That's why this answer is zero. So in this example, we want to know whether A and B are mutually exclusive. All you look up for is probability. Look at this probability. When you look at this probability, what does it mean? Is A and B is number of outcomes for A and B divided by and of total sample space. So what they basically this is saying is this piece is giving you 0.15 divided by 1, which is actually 15 divided by 100. So that means there are 15 outcomes here. What it means is n of A and B. See, there is an intersection for A and B. There is 15. There are 15 students. So this cannot be. So this is an example, maybe two group of students, maybe some of them like soccer and some of them like some of them, let's say soccer, and let's say this is football. So that means there are some students who like both. That means 15 students like both. That's what this means. And A is 25 students like soccer, and this means 60 students like. And you remember when I added up, it becomes 70. That means 30 students don't like nothing. So this is the understanding part of probabilities, where uh, one more thing is this piece is this is this is that A and B is, right? And if you want to know exactly what is this piece here, if you see this piece, this is actually A, but not students who play soccer, but they don't play football. It means you take away football from it. In other words, in the set theory, right, A and intersection B complement. It means not B. So A but not B. So that's another way to write down this. If you want to write the other piece here, so this piece, this part is is it is this piece is B but not A. That means it is B intersection A complement. So that another way to write that. So hopefully we got an idea of understanding what is the meaning of independent, what is the meaning of mutually exclusive. So for mutually exclusive, all you look up is if the probability A and B, if this is zero, when we say they are mutually exclusive. But this time you saw this intersection is not 0, 0.15. So there is that 15 students who play soccer and football. So we say they are not mutually. So these are not mutually. So to say two events are mutually exclusive is that you have to have probability of A and B has to be 0. Another way to see also is if two events are uh, let me clear this. Uh, is if these two pieces are given, if two events A and B are independent, sorry, mutually exclusive, if probability of one thing is A and B is 0. You just have to say if probability of A and B is 0 and probability of A, uh, okay, I think that just wanted to show that. Okay, this is question number 4. Compute the following probabilities in connection with the roll of a single fair die. So there is a fair die here. Let's see, this is the fair die, 1, 2, 3, 4. So when you roll a die, you can see the sample space is 1, 2, 3, 4, 5. These are the 6 uh, total number of outcomes that you notice shows up on top here. The first question is, what is the probability that the roll is even? So let's call this as A, and that the outcome number shows up is a roll even number. And when you look at it itself, you know the probability. We want to know what is the probability of A, right? So how many possibilities are there? So it's a ratio of all, and these are, see, the number of outcomes, total outcomes in the sample space is 6. So this will be 6 here, and the number of uh, outcome favorable to the event A is, that means the A itself, that you can have either 2, 4, and 6. So there are three options here. So this is 3. So this answer becomes 3, which is half. So this is straight away directly using the basic probability definition formula. Next is find the probability that roll is even. Okay, so this part we have that A is called a roll is even, and given that it is not 2, so we have to write another probability. B, let's call B is a rolling not 2. So roll not 2 means it is other than 2. When you say roll not 2, basically it is 1, 3, 4, 5, and 6. These are the outcomes which are not. Now, by conditional probability formula, so probability of uh, B has occurred, so B goes down and this goes here. We want to know what is the probability for chances that uh, it is going to be even when we know that it is not 1. So what is this by definition? By formula conditional, it is probability of A and B divided by probability of B. Now, from here, what probability of B, the denominator that we want to know this, right? Is there are 5 of them, 1, 2, 3, 4, 5. So this is 5 out of 6. That's the probability of. So this denominator will be 5 out of 6. But then how many are both? So we need to know a number of. So this means n. Let's say how many outcomes are favoring that it is A, it is even, and also it is not B. Sorry, not 2. And you can see this piece that you see here. These A is this 2, 4, 6. And in these two cases, what do you see common? Let me write like this. So for this piece and for this, what are the ones which are, how many are common? And you can see, so 2, 4, and 6. So this 4 is right here, and this 4 and 6. So there are two of them. So the probability of both, with probability of A and B is 2 out of 6, not this 2 out of 6. So this will go to 2 out of 6. Using keep change flip, okay? Using keep change flip, you can write 2 out of 6 times 6 out of 5, and you can see this crosses out, you get 2 out of 5. And you're done. So that takes care of this one. But you can also use instead of this, you can use alternative method called reduced sample space. Now, what is reduced sample space basically means? Let me take off, clear this, what I'm talking. So we could also use directly. Now, what this means, given that we already know, this means probability of, we want to know when B has happened, right? So B is the, so how many outcomes are favoring which are not 2? And you can see not 2 basically means there are, if I take away 2, there will be only 1, 3, 4, 5, and 6, which are already 5 of them. So these are 5. So that goes 5 down. And among those, how many are even? And you can see the even ones are, sorry, this 4 and this 6. So there are 2 of them. So directly you could also write that it is 2 out of 6. But better to write the conditional probability formula to get the answer. Next is, what is the probability the roll is even given that it is not 1? Now let's call C is another new event where not roll not 1. So if it is not 1, basically means the number that shows up on top of the dice is these are the possibility. There are 5 of them. Okay. So we want to know what is the probability of this one is A. A is already we know is even, right? Rolling a even number. So we want to know what is the probability of A when it is not 1. So this is what that means by definition. It is probability of A and C divided by probability of C. Now, probability of C, you can see there are five of them, so 5 out of 6. That's the thing. But what about this piece? So the down portion will be 5 out of 6, and the A and C. So how many are even as well as not one? Now remember, even is 2, 4, and 6. So which are the ones which are even, and they should not be one also? And you can see. Okay, I think I made a mistake here. This should be not one means this should be two. So this is just wanted to make sure. But okay, I'm sorry for that. And hope you guys understood this piece. So now A is even. So I wanted to know how many have even as well as not one. And you can see 2, 4, 6. 2, 4, 6. It is appearing here as well as here also. So there are 3 of them. So we just write. So the probability for that to happen is 3 out of 6. So keep change flip, keep the numerator, uh, flip the division to multiplication, 6 to 5, and you get 3 by 5. Okay, so this is how we can solve this. So a lot of two different ways to do is one is this one. We can also use directly. Let me claim this. Can we use reduced sample space for this? What does that reduced sample space? Given that it is not one, that means you already know it can be 2, 3, 4, 5, and 6. That means probability of not one. Uh, so this is it is even. Given that it is not one, and you want to know it is even. Even when you know that it is not one, right? Not one. So it means it is you have to the samples is not going to be even though the S was 6, but now it is reduced. You are saying not one. It means the other than one is 2, 3, 4, 5, and 6. There are 5 of them. See, and even how many of these are even here? And you can see this is 2, and this is 4, and this is 6. So there are 3 of them which are even. So this becomes 3 out of 5. So this is a direct way of figuring out the answer. So this is question number 5. So following are the probability in connection with two tosses of a fair coin. So let's say this is a coin. It can have head up this side and other side is tail. So when a coin is tossed, two coins are tossed, head, tail. So what are the total outcomes in the sample space? What are the possible options? You can see this is either you have head or head tail, or the first tail and the second head, or first tail and the second tail. So there are altogether 4 of them. The first question is what are the probability the second toss is head? That means we have to let's call this as let A be uh, second head. I just write second one is head. Second one is the head. So when you roll 2 coins or when you toss 2 coins, the second A is an event where the second coin, that means this coin shows up head. That means the option will be tail and head. So that means this is one option, or it could be head and head. So you can see that there are 2 options there. So straight away we can write the answer for this is probability of A that second head is 2 out of 4. These are the sample space, which is n of s. Just to get an idea, this is n of a. So when you write probability of a, it means it is this divided by that. So you can write directly for 2 divided by 4 and you get half. Now we have another question. Say find the probability that the second toss is head given that. Now this is the condition given that the first toss is head. So we'll have to write down this as B. So let's call B is the first head, the first toss. The first toss is a head. Okay. So that means we need to find probability that you already know that it is first toss is a head, and you want to know what is the chances that the second one is head. Now, by definition of conditional probability, this is probability of A and B and divide by probability of B. Now, let's write down the outcomes for this. So, what are the outcomes that the first toss is a head? So, you can say head, head, or it could be head and tail. These are the two options. That means there are two of these. That means so the first part, probability that to have first hit, that means there are two of these, right? It will be 2 out of 6, okay? And the probability of B, which says, sorry, this answer should be, so this will be 2 out of 6. But the top one, how many of them are, uh, so what is A? Let me put the color here. So if you see this case and if you see this case, what are the common ones? And you can see this head and head, these are common. So that means there's only one out of. So that means this can be probability is 1 out of 6. Okay. So when you do this keep change flip, it becomes 6 over 2, and you end up getting half. We can also, is there another alternative way to do this? And you can see we can use reduced sample space. That means once you know that, so directly also we could write this answer. So of course, this is the right way to do using the conditional probability. But if you want to use the reduced sample spaces, you already know the first two tosses is heads, right? So that means there are two of these. So that means out of this, and the one that are common, that means the second toss is head. So these are the one which you can already clear see there's only one where the second is head and the first one also is head. So that means there is only one. So 1 out of 6 and you're done. Let's do the second part. Huh. Okay, C is the second head. So it means you want to know probability that remember A is the second one head, right? Let me remind either it is HH and TH. This is A. Now probability that this, when you know that at least one of the two tosses heads. So let's call C is at least, at least, at least one toss is head. It means C can be if either both could HHC. So either one of them is a head, first head, second tail, or first tail. So these are the only option there. At least, what is the meaning of at least means opposite of uh, no tails. So at least one head, at least one head actually means no tail. That's what it means. It can have one head or it can have two heads also. That's why there are three of these. Now let's put it, this is C. So let's put it C by conditional probability. This will be P of C and the top will be probability A and C. Now A and C, okay, what is common? I'm going to use the color here to show that this, so the pieces that are common is this H is right here, see, there is one, and also this TH is right here. So these are the two which are common. That means probability the A and C is 2 out of 6. Okay, and then probability of only C, because this there are three of this. These are three, 1, 2, 3. There are three. This is 3 out of 6. And you can say you use a keep change flip and you get 2/3 and you are done. Another way to show this is also by using reduced sample space. That means what you said, you at least one of the two tosses is here basically means there are three of them. So these are the three. So that's why I say this three comes at the bottom. And out of these three, how many are favoring A? And you can see that HH and TH are outcomes that are a part of the C. And that's why there are two of them. So then you just put 2 out of 3 straight away using common sense. I hope so. This was question number 5. Uh, so this is question number 6. A special deck of 16 card. Okay. Uh, a special deck of 16 cards. 4 are blue. You can see I already show the blue there. 4 are yellow, and 4 are green, and 4 are red. All are shown. 4 cards of each color are numbered from 1 to 4, and you can see this visuals is very clear. A single card from this is 1 is picked up. What is the what are the probability that the card is going to be a red card? And you can see there are altogether 16 cards, and probability of, so this is probability of chances that the card is a red card will be equal. That means there are 16 cards altogether. You can count them, and out of these there are 4. So you can see this. These are 4 red cards. So 4 out of 16, they have 1/4, which is 0.25. Well, I'll just keep it this much. This second question is, what are the probability that the card? So probability that. So for this, we can use probability that a card, given that it is not green, that means we are probability of red card, given that uh, given that it is not green. So we can use reduced sample space. What that means is the ratio should be, you already know that it is not green. So if it is not green, it can be yellow, red, or blue. That means there are 12 cards. And so not green could be blue, it could be yellow, it could be red. So that means out of this, of each one has 4, 4, 4, and you can see these are 4 red. So that goes right here. So this is 4 divided by 12 is 2/3. The third question is, find the problem that the card is red and it is neither red nor yellow. So let's put it like this. Probability of card is red and it is known that not red and not yellow. So that means how many cards are not red and not yellow? So that means it will be not red and not yellow. So that means 8 green, 4 green and 4 blue. So that will be 8 here. And from this, whichever the cards that you see, this blue and this, how many are red? And you can see you don't have no red. So it's like 0. So this answer is 0. And the last question is, let me see here. this piece. Red, probability of getting red, given that it's not 4, not 4. Now, what is the meaning of not 4? Now, in the cards, not 4 basically will have to take off should not be 4. It means this should not be there. No 4. There will be 12 of them. That means the answer will be out of this 12. How many are red? And we can clearly see that means there are 12 cards remaining. If you see there are 12, so 12 out of 12, how many are red? You can see there are only 3 out of 12, which is 1/4. And you can get the answer, and we are done. And I hope that makes sense. Okay, this is question number, again, same question, but let's see what the question is. What is the probability the card drawn is 2 or 4? So the card drawn is 2 or 4. So that means we have to take off this and this from each one of them, this and this. So altogether there are 16 cards, but we have to take off 2 and 4. So what are remaining is 1, 2, 3, 4, 5, 6, 7, and 8. So this becomes 8 out of out of uh, out of 16 cards, which will be half. Next question is find the chances that the card is drawn is 2 or 4, and it is given that it is not 1. So if it is not 1, uh, so not 1 basically that means this is not, this also no, should not be with this. So how many cards are remaining when you take off all the cards with 1? So that answer is going to be out of 12. And from this remaining, you have to have 2 or 4. So if it is 2, 4, so this is 2 and 4, again 2 and 4, and 2 and 4, you can clearly say there are 8 of them, and you are done. So the rest is you divide by 4, you get 2/3. So hope that makes sense. And next question is find the probability that the car is 2 or 4. So same question, but this time given that it is either 2 or 3. So you have to have keep 2 and 3. That means this and this. 2 and 3 has to be there, not the other card. So you already told these are the cards that they are either 2 or 3. So that means there are 8 of them. So this is going to be, so 8 cards are there altogether because you're being told that it is either 2 or 3. So then I've shown you that. But then among these, how many are 2 or 4? So a 2 or 4 will be, let me check up this two, and these are the ones which are part of the whole group of 8 cards. So 2 or 4 will be, because 4 is not even though it says 2 or 4, but in this card 2 or 3, there's no 4 cards. See, this piece, when you say the card is either 2 or 3, that means the card does not have 4. That means then we have to look out for 2. And 2 is here for 4 places, 1, 2, 3, and 4. So it becomes 4 out of 8, and you get the answer. The next one is find the probability that the card is 2 or 4. It's given that it is red or green. So this is red and this is green. So there are 8. So this is out of 8 because the probability of 2 or 4, given that it is green or red. So that means there are altogether 8 of them. So these are the 8 of this. Which one are 2 and 4? You can say 2, 4. 2, 4. These are 1, 2, 3, and 4. So you get 4 out of 8 and you get half. And that completes that. So the question number 8, you are given a table. All you do is first step, such this kind of problem is better to complete the table because this is a two-way contingency table. So we have to know what is the total probability of each one of them. So if this is A, the probability of A is you have to add up 0.12 and 0.18, you get 0.3, 0.18 is 0.30. Then the B, probability of B becomes 0.70. Then R is probability, you can check this, 6 and 1. This is total, this in row and column also. The first question is asking what is the probability of A. So probability of A is, and you can see A, the total probability of A is this plus this, which we already added up, and that's why I say probability is 0.30. Then probability of R is right here, 0.4, and A and R is this piece 12, which is 0.12, because A and R means the one that is for the row and the column. You can see this is the cell that helps. Now we want to know the second question is whether they are independent, A and R. Are these two independent? How do we know independent? So the multiplication rule A and R, if two events are independent, provided it is product is the same. So it is, if this is true, then we say that two events are independent. Now A and R you got 0.12, and this goes right here 0.3, and this goes right here 0.4. You can clearly see it is equal to 0.12, and that is correct. So they are independent events. A and B are independent. Then based on B, whether or not check whether or not this A by R can be predicted without any computation. If so, make prediction. In any case, compute this using the oh they want it, and we can easily know that because they are independent. It's quite obvious that A when R is same as probability of A. So that is because of this PC. But they still want us to check with the help of so okay, let's put it like this. So this by formula is probability of A and R divided by probability of R. Mhm. Now A and R is 0.12 and R is here it is R is 0.4, which is 0.40, which is 12 out of 4 or out of 40. So this will be 12 out of 40. And use the calculator or check, it becomes 0.30. And 0.30 is this here it is probability of A. And if you We check problem number 9 is the same as the one that we saw. The same idea, just find the total like this, okay? And then find A, R, and then check. Same thing you do, and find out the whether they are independent or not. So here, so let me go directly to it. Okay, suppose event A and B are you are given a probability of A and B, and the question is find whatever the so the first question is probability of A. Now probability of A and B, if you see this, uh, they the right way to do could have been probability A is probability of A times probability of B when A. This is one formula, or probability of B when probability of A when B occurred. So we don't have no enough information to find this, even though they gave us these two pieces, and these two pieces are missing. So we don't have enough information to find this A and B. But look at the second question there is what is this with extra information there? Oh, this is so what is the meaning of independent means probability of A and B is probability of A times probability of B. That's because of the definition. If two events are probability of B when A occurred is same as probability of B. See, this is correct. And that's why in the multiplication probability that A and B I write is is probability of A times probability of B when A has it. So this answer is same as B, and that's why we write this. And now that you have these two things, you just multiply, you get the answer 0.7 and zero point 0.3, you get 0.21. Second question is mutually exclusive. So if they are mutually exclusive, it means A and B do not both events A and B, they don't have it's like there's nothing in common in between the event A and B. So if I want to find probability of A and B, it means it means it is a number of favorable outcomes in A and B and to n of s. That means that this is zero. That means n of A and B is zero. So it means this is zero over whatever this total n is, and you end up getting zero. So the moment you have two events A and B are mutually exclusive, we say probability of both happening at the same time is zero.